All right. Yay. So today is Wednesday. Your quiz one was yesterday, so you should see your grades already for that. And you can check it out. I went through some of the questions that might have been a little confusing, and when there was a huge percentage of people who selected a different answer than what I was expecting, I gave them credit for that one as well. So I think there were two questions, one with the Git branch one and the SQL one that I went through and kind of gave multiple groups. Well, the SQL one, I had the wrong thing there for a while, so they didn't have a right answer in there. So tried to fix that up. If you are going to argue for credit, please follow what is listed in the syllabus. Exactly. There's 142 students this semester. That's a lot, and it's a lot more than I'm used to. And it's really important to follow this format as specified. For each question, submit the following. Put 1 dot quiz number 1, 2 dot quiz question number, because your questions sometimes will be random from other questions. Like I don't even know which question number 3 is, or the one you're talking about is the SQL one. Is it number 4 or 5? You got to follow this format. It makes it a lot faster on myself and my grader, TA, to get through and answer you. And if you don't do that, then I'm not going to be able to do as much of this for you guys because it's just too time consuming. So please follow this format. Using Jing. Jing is really easy. It's installed. It's on all different platforms, and you can just pick a spot, and then you can capture an image and download it or upload a stream. And for video, you'll be able to, once you have it installed, it's this little yellow bubble. You can select, you can click on capture a video, and it will also include the mic, so you can talk through a video, and you can scroll through and stuff. And then when you stop it for the videos, instead of downloading the video and then uploading it to Moodle, because that's just a lot of extra work also on my end for grading, just click on the link that's share via screencast, and that will upload to the cloud under your account, and then it'll just have a URL link that you can paste. And then that way we don't have to download for like 5 minutes each of your videos, because again, there's 142 of you, and I'm going to be asking you to do some videos this semester of your work. And that just takes forever. So I need you to do the link so that I can just click on the link and go to the web page and then watch your video. So that's a heads up on that. Your argue for credit. So take a look at the schedule. If you're going to argue for anything on quiz 1, it's due on Thursday. Always check the schedule. And remember at the top it has the deadlines, the times. So it's at 11 a.m. 11 a.m. are the deadlines. So Thursday at 11 a.m. is argue for credit for quiz 1. So that's pretty much for all the quizzes. You have essentially about a day and a half or 2 days, depending on when I get it released. The reason it takes a little while to release a quiz, like on yesterday, is I was manually going through, looking at the statistics of it. Were there any questions that were confusing? Do I need to give partial credit to some questions? Or like I said, I gave full credit to some people who had. And when there was a bunch of you who read it differently or just had a different idea for the answer, I gave you credit for that. So I need to look at and analyze it before I release the quiz scores. And in some quizzes, there might be manual grading. So that's going to take a little bit of time on that Tuesday, too. I will always post the discussion board when the quiz is ready for review. And then your email to the course email, not to myself. Again, I have a TA who's helping grade, so I needed to go through the course email. Is due by Thursday, 11 a.m. to argue for credit. Any questions about the quiz? Okay, so any question? Okay, practice. So on Friday, the idea is we're going to just finish up some Java stuff and go through the practice problems, whichever ones make sense or that you want to cover. And then have some time to work on quiz 2, which is on the Java. And so the practice, again, I don't collect the practice problems. This is for you to practice with. And if you looked at quiz 2 already, you'll notice that some of the questions are based on the homework or practice problem. All right, so you still want to do it, but you will get graded on the quiz, but you don't have to submit your answer. Part of that is because, especially on quiz, or this first practice problem, it's really key to understand kind of the differences of answers and what's good about them and what's bad about them. And so the idea of this one was, like, last week and this week, we're kind of learning Java, and specifically object-oriented stuff within Java, and making sure you understand some new concepts you probably hadn't heard before, like interfaces, abstract classes, polymorphism, things like that. And so we want to apply that in Java. We'll also talk about static today, instance of an array list, get class versus each. And so trying to get some really good foundation for this class is understanding the objects, object-oriented programming. And so the first one is writing a static method, making sure you understand that. We'll talk about that today. And then this question number 2 and 3 are the big ones. Like, this is where you get a piece of what it's like for this class. It's not just about getting something to work, but we want to look at how is your design good enough so that in the future when we extend it, it's still going to work. Or you have to add a lot of code because of the way you implemented it. And that's what I want to talk through and make sure you've gone through it yourself first, and then on Friday I'll show you, and then you can bring up and say, hey, well, I did it this way, what about this? And we can discuss, hey, yeah, that's another solution. Or, okay, well, what's not so great about it? If we try to add audiobooks and these other things, what happens with your solution? And then we can have that amazing discussion. So this is a huge, this is one of the big learnings this semester, is going through this problem number 2 and 3. And so you're working with some code, the media book and DVD classes, and you want to print them out. And you're going to be using the comparable interface. So you can look up in Java, we might have some time today, talk about how the comparable interface works with Java. Essentially what it's going to do is if you implement that comparable interface and you create an array or a collection, an array list of those objects, you can call the sort method. So arrays is a class in Java, arrays with a capital A. It has a sort method, so you can do arrays.sort on your array. ArrayList also has a sort method. So you could take your ArrayList.sort, collections.sort on your array list, and it'll sort. And but you have to implement this method, implement this interface. Did anyone look up what the comparable interface has? We know that interfaces have methods you're required to write. What's the method? The compare to method. And so that's how it's going to do the sorting, is based on the compare to method. So the nice thing is, as long as you implement that part, it'll do all the sorting for you. But there's some tricks in there, how you implement it, which class in the hierarchy implements the interface, and then what you do in the code, and is it extendable? So anyone who's already started it, you hopefully have seen some of these, wait a minute, how am I doing this, and is this going to work, and is it going to extend? So that's what I want to talk about on Friday, and that way it gives you time to make sure you've gone through that. And then there's a bunch of really good questions just to make sure you understand stuff. And so we'll just talk about as many as we can on Friday that we can get through. All right, questions about the practice problem. And then hopefully on Friday we might have some time for you to start or work on the quiz, or if you have questions about the quiz on the Java, you can ask them too as well, because you always have a week to do the quizzes. Okay, so last time we were working, what was our class hierarchy that we had? And what was the top? Was media an interface? So we had a media interface. And then what was our top class? We had book. And who inherited from book? Textbook. And novel, what was the other one? Oh gosh, that long word. All right, so that's what we were working with last time, and we talked about polymorphism, right? What would be an example? This is on your quiz for the next one. Given a class structure, give me an example of a polymorphic reference. Yeah?
Book equals
All right, so book B equals new novel. We have our book. We can set it equal to a novel. This is the polymorphic reference, this B. We can also then change B to be equal to a new textbook. Oops, I got it uppercase this time. All right, this is still polymorphism, that this variable can be referencing a novel. It could then change to a textbook at a later time. So this is the beauty of inheritance, as well as what's another example with media. Remember this, we'll talk about UML, which is the Unified Modeling Language for this class diagram. We'll get into the details of that later. Right now, just know that book implements this particular interface. So if I did a media example, so we can set it equal to any of these. Because book implements media, then all of these inherit that implementation of media. Okay, so these are polymorphic references. And so understanding that's huge. We're using polymorphism a lot. Question?
What's the difference between the dotted line in this case and the solid line?
So the dashed line is implements an interface versus a solid line with this open arrow is inheritance. So these inherit from book, and book implements a particular interface. We'll get into that with the UML as well. We'll get into details. You'll be tested on the notation for UML. Is there another question? Okay. So we also talked about we can do this as an array, right? I can create the library. So I could say book. I think this is what we did last time, right? Library equals new. And the way we do it in Java for a new array like this, we could do something like that. Book library equals new book. So there's 3. And now each one inside here, library, index 0. Okay, so we can put the different types in here. This is also polymorphism. And arrays you should be familiar with. That's basic programming construct. If we were to loop through this array, let's do int I equals 0. In Java, you can do I less than library.length. So it's a little bit different than C++, I++. Now, what can I do in here? So I know I'm at a library at index I. What methods can I call on there? Can I call, let's just say ABC is a method in here. And DEF is down here. GHI is down here. JKM. Does that make sense? So these are just methods in the specific classes. Can I call ABC on library?
Yes.
So ABC would work. Can I call DEF?
No.
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 Now, here's the thing about the polymorphism. Because library, what is the data type of library? Book. We cannot say whether or not it's textbook, novel, or periodical right there. So we don't know whether that method exists. Like, because the first one, it's a novel, so only GHI would work. DEF would not work. So since library, all we know is it's a book, we can only guarantee that the methods in the book are in there. What if media has the method XYZ? Can I call library.xyz?
Yes. Yes.
Oops. Oh, my goodness. So that will work, too, because we guaranteed book made a contract, say, I implement this interface. So either I've written the XYZ method or my children have. But I guarantee XYZ is available to you because it's at the book level. What if we'll say sentiment, which is like an NLP if you're trying to figure out the aspect of the periodical. So let's say this is an interface that has RST as a method, and periodical implements that interface. Would I be able to do library@indexi.rst? If only periodical implements this interface, then library, the book, does not know about it per se. Only periodicals, and we don't know if that's a periodical or not. Does that make sense? So it's knowing what level and what scope you're at. Now, what if, this is not what we normally would do, but you could say if the library at index I is instance of, so this is one of the Java keywords, if it's instance of periodical, then can we do library@indexi dot, oh, can you still see? So can I do this? Library@indexi dot JKM.
Yes.
Yes.
You need casting.
You have to cast it.
You have to cast it. Because right now, library@indexi, even though it is an instance of periodical, this is true, the if statement. When we get to this statement, it's still library@indexi. It's, all we know is it's a book. And so we would have to do a cast periodical. And I usually would create a new variable, so we'll just say periodical p equals library@indexi. And now you can say p.jkm or p.rst from the sorry, distant students. I guess I disappeared behind the crowd. That's interesting. I'll have to watch the video. I've never done that before. So once we've cast it to a periodical, now we're dealing with a periodical object. So I can call JKM. I can call RST. I can call ABC. I can call XYZ, because they're all available to that. OK. Now, similar to the array, another very, very common construct is the array list. This is how you construct it. It's very similar to a vector in C++. There's also a vector in, array, in Java, too. This is essentially an object version of the array. And you can add list, add. Is it just add? Oh, my gosh. I'm doing like C++, Python, and Java in one semester. I think it's just add, yeah. So list, new novel, or whatever. So you can add to this. An array list, it's the same thing we did in C++. Probably in data structures, you might have had this problem where it's essentially using an array in the back end. So you have all the problems that an array has, but they've written all the methods to make life easy for you. So like if you wanted to insert in the middle of the list, instead of you manually moving each element down in the array, because it's contiguous to memory for arrays, it does the work for you. So worth looking into. The array list is a very easy one to work with. For arrays, you have to know the size when you create it. And that can be a limiting thing. Like if you're reading in from a file and you don't know how many entries are in there, a lot of times it's easier to use the array list. It's still going to do array doubling in the underlying structures. But as a programmer, it's just higher level and easier to work with. So highly, highly recommend working with array list. Same thing, though. You can do the for loop through the array list. When you do a for loop in an array list, slightly different. You have I less than list.size. Size is a method call. So for an array, .length is a constant, because when you declare the size, this 3, that's the size, it's a constant, it's not going to change. So that's why it's .length with no parentheses or anything, it's referring to a constant. For this, for an array list, you use .size, which is a method call to find out the current size of the array list. And then you can, inside your loop, do something. You can do the same thing with the array list will work with the square brackets, as well as you can call the get method. So list.get at index. Yeah?
Going back to what we were talking about before, I just have a quick question. If media had a child, would we be able to reference it through library?
So if media had a child, we're not going to go down that route.
Okay.
You can have inheritance with interfaces. I don't see it very often. And yeah, I mean, it would inherit it, but we're not going to have to deal with that this semester.
Okay. Thank you.
Okay. So this is big. This is really, really big. Okay. So then now, what's going to happen with your homework? The question is, I want to be able to sort, whether it's textbook, novel, or periodical. And so, and your homework's a little bit different. I think it's book and DVDs, and then MP3s. And the big question is, when you're at the top versus down here, who implements that comparable interface? So you want to research about comparable, how that works. The comparable interface, like media, that's going to have the compare to method. Compare to method is going to return a negative value, a 0, or a positive value. 0 meaning that the values are equal. Negative if one comes before the other, and positive if the other one comes before the other. And so when you have to write the compare to method, you have to figure out, well, do I put it down here? Do I put it up here? And we'll talk about this on Friday, but I really want you to try to go through it, because what you'll find is as soon as you have 3 or more, there's these little problems that pop up. And you're like, well, wait, how do I deal with that in a good way? And that's what I want you to think through. And we'll talk about a bunch of different options on Friday about that. So that's the sorting and for that homework, the comparable interface. Okay. How many people have already worked on that problem, at least a little bit, so you've seen some of it? Okay. Again, please work on it, because it makes Friday really interesting. All right, so we just talked about instance of and array list. We do have static to do. Static. Okay, so, oh, can I flip it? Is this allowed? Oh, wait, can I use this? Wait. Okay. I want to keep this, but have something else as well. Are you coming in? Or are you going to, whoa, magic! Sweet, okay. I should probably put the marker down. And is this finger?
Like the Wizard of Oz?
Nope, that's not it. I have to learn how to use this. Okay. Oh. Oh, okay. Thank you. From the world. Okay, so what was I doing? Static. All right, so let's say we have...
That's the eraser.
It's like I've never used a drawing tool or something. It's just weird with all of you watching me. What's that logo, badly drawn?
Looks like a glove.
McDonald's.
It's McDonald's! See, we get to talk about McDonald's in this class. All right, badly drawn. All right, so now if you remember with McDonald's, at one point, I don't think they do this anymore, but they used to have a number down here. Do you remember what the number was? Like number of billions of people served or something? I don't know if it was accurate, because the number would just keep flipping up, like, oh, look, we've like served billions and billions of people. 1, 4, 3. Hopefully this isn't your passcode. It's not mine. Oh, that's my favorite number. Okay, so I had some number in here. Supposedly, when you purchased, where's a McDonald's in Boulder? You guys must know, right? Because it's cheap still. Or have you gotten to the point where it's like, I cannot, it's not food.
Yeah.
Like, I can't. Oh, nope. So baseline, where's another one?
28.3.
28.
28.3.
28. And one more.
Denver Airport.
Okay.
Denver Airport.
DIA. Okay. So each time somebody buys at baseline, the number goes up. And if you buy at 28th Street, the number goes up. And so what's happening is all of these guys, all of these locations of McDonald's are sharing the same sign, the same number, right? So this is what we're talking about for a class variable or a static variable. So normally we create a class. So let's say we create a McDonald's. This is really weird. That's more fun. I hope you're okay with me in the back using my fingers. Yay! Okay, so public class McDonald's. What would be an instance variable that we would keep track of for McDonald's? An address, right? So instance variables are usually private. Oh, maybe I should use the pen. What's the address? We'll keep it simple right now. We'll call it a string. And one more.
Number of owner. Yes.
Owner could, well, let's not.
Manager.
What's guaranteed to be different?
ID.
Is
The phone number? Okay, so that means each instance has their own address, which is DIA 28th or baseline, and their own phone number, which might be 121 122. Nope, that's a 3 now. 42 1422. That's their extensions or something. So those are all instance variables. Every instance of McDonald's has their own values. When we're doing this McDonald's sign, we had to share that same value. That's a static variable or a class variable. So here, whether it's private, this could be, depending on our situation, whether it's public, private, or protected. This is like, we'll just keep it simple and call it an int. And we'll say num sold, and then I forgot the, wait, hold on. Yay, I got it down. So the key here is we add the keyword static. So static means it's shared among all instances. So even though their phone numbers and the addresses are different for each instance, they all share this value. So if we create a method for selling a burger or selling to a customer, if it's in baseline, it updates the same number as all of these. So that's the best example I came up with for a shared class variable. Yeah.
Oh, the kind of thing we were talking about where the owner might be the owner of multiple different, but it doesn't have to be. Can you use private for that? Can you not?
Okay, so
static.
Let's finish up static. Is there any questions about static and class variables? And yeah.
So to be clear, when you update the num sold for baseline, it updates for 28th as well?
Yeah. So if I were to call public int, nope, t, get num sold, I would be just returning num sold. And actually, because this is a static value, I would also want to do static in here. And that we're going to talk about a couple things for that. Sorry, what's your name, but the owner guy?
Danny.
Danny, remind me when I finish static to come back to that, because that's actually the great next topic. But I'll forget, so yeah.
So for the homework, when it says to call the method statically, that is how you call the method statically?
Okay, so that's what we're getting into right now. So when I call get num sold, if I were to call it on the baseline instance, so let's say let's say I'm in another class, and I have a baseline instance. So I have McDonald's, that's a D, the baseline equals new McDonald's. I can say baseline dot get num sold. And so I'm going through this instance to access the get num sold, and that works. And even if I did from DIA, did DIA dot get num sold, it'll refer to the same value. Now, because it's static, there's another way to access this variable, or this method here. So we can also do, because it's static, I can say McD dot get num sold. Does that make sense? This is the name of the class, the actual class. And I can call, because this is static, I can call it directly, the class variable, the shared variable, and find out its value. Now, if I had a non-static method in here, like public string get address, can I call mcd.getAddress? Why not?
Not static.
So mcd.getAddress will not work. And think about it. If address is an instance variable, what does it mean to ask McDonald's as a whole, like that class, what its address is? That doesn't exist. But baseline.getAddress, okay, for that instance, the baseline instance, there's an address for it. In DIA, there's an address for it. For a class variable or a static variable, we can do the name of the class dot the method name. Yeah?
Does that mean static methods can only work on static variables?
So yes, static methods can only work on static variables. Because otherwise, what instance would it refer to? You don't know. So static is a big one. We will make use of static in some of our design patterns. We will see the use of a class variable to make use of. And for example, a very common one might be, let's say you're doing something for the forestry register and you're simulating ducks in a pond and how that would work. You're doing simulations for that kind of thing. You want to keep track of a count. How many have been instantiated and how many have died or whatever. And you're keeping track of that in the simulation. You want a shared count of the number of ducks created and ducks lost to whatever variables are happening. So every time you create an instance of it, you want to update the count. So that would be an example of where we use static. Yeah.
Can a static variable be used in a non-static method?
Can a static variable be used in a non-static variable method? Yes. Because any instance has access to the static variable. The static method can only access the static variables because you might be going through the class name and there is no instance in memory for that stuff. All right, so this is a big one. We will be doing this. We'll see this. We'll see this a lot in Java. For example, when we do get instance, which is following the singleton pattern, a lot of times when you do say like calendar.getInstance or number.getInstance, all of those Java methods are making use of this static. Did I touch it? Did I touch it? They make use of that static. And so we'll do it too because we're going to learn the singleton. We'll also see the example of that count, like a simulation. Okay, static makes sense. Are we good? So let's go back to the owner concept. So the question was, what if McDonald's had multiple owners or the same owner for multiple restaurants? So one thing we would do with owners, as well as I'm going to get rid of this because we're done talking about that. For owners, Look at it slow. Follow me. Okay. It's the little things in life that amuse me. That's why I'm so happy. Okay. So it came back. Okay, that was not amazing. Okay. So for something like owner, what we would normally do is do something called composition. So I'm going to keep in here a private, most things are private for instance variables, and I would keep track of a person object and identify it as owner. So the big thing with object-oriented programming is we have multiple classes and that we would want to make use of them. And he might be the owner and the manager. And what would happen is when we create an instance of owner is going to be a whole other class. So we'd have another class called owner.
Person?
Yeah, thank you. I was just checking, making sure you're paying attention. Once on an exam, someone came up to me and asked the question, and I said, do you remember the lecture about McDonald's? Boy, he gave me the funniest look. I'm like, you obviously were not in class, because you would remember that. Class, person. All right, and this would keep track of then their name and such. And then what we could do is when we have baseline McDonald's, we can say set owner to this instance of that person. And let's say I created a person me equals, that's a new person. We'll say it's L. So I could say set owner me, and then the DIA one. So if I had a DIA instance dot set owner. So what I'm really doing is I have this class is composed of that owner, and then these two instances are pointing to the same object that I am. I'm an object. I'm just an object. Don't objectify me. Nope. Not as funny as it was in my head. Okay. So this is what we would want to do. And this is composition. So this class is composed of this. And part of what we're doing with this, and we'll talk about object-oriented design principles, that we would do delegation. So anything to do with owner, like setting the name, their phone number, contact information, and address, we delegate that to this other class. So this is a big part of how we do the object-oriented programming stuff. Does that make sense? Yeah.
So B is always going to be referring to the same object, right?
Yes.
Change something in B, that changes propagation through the same.
Right. So the question is, me is the same object. So if I were now to do me dot set name, because I change my name a lot, in Fort Collins I'm known as Zill. Secret, don't tell anybody. Now everyone knows. And here I'm known as L. New Zealand I was known as Lizzie. I just like changing. Okay. I'm not wanted or anything. It's just, let's play with that. So anyway, if I set my name to Zill now, if I were to ask baseline.get owner and get the name, it would now be Zill. And same with DIA, get owner's name, it would say Zill. So it's going to propagate through all of them. It's the same object that it's pointing to. So yeah, and that's a big, big thing. So objects, getting used to this idea of the object-oriented programming. Hopefully you all came in, it's a prereq that you already know a little, how to program object-oriented, at least objects itself, because that kind of mentality is a little bit different, quite a bit different than procedural programming. And so we're going to get really in-depth with objects this semester, because that's what this whole class is about. Questions on that? Okay, so static. Let me bring up, on the slides, that's the wrong class. On the slides, I had a list of what you should know from Java and what we don't really need to know. So let's Go over that real quick. I think it's one of the last slides. That one. We're not really going to do much with exception handling, like try-catch. We'll probably see it once or twice for exceptions, but it's not. It's really, that's just getting into robust programs that handle all the bad scenarios, and it's just tedious work. So we're not going to focus on that. But we did talk a little bit about the array list. Totally worth getting familiar with, very similar to vector in C++. Classes, understanding what an instance variable is versus a class variable, static variable. So static variable or class variable. Static is because the Java keyword is static, but it's really called the class variable. It's shared with all instances. What's the keyword for constant in Java? Final. Final makes it a constant. Now, you do need to know about a constant, just final for a variable. There are ways, I don't think we're really doing this, but you can use a final on a method so that it cannot be overridden in the subclasses. We don't do that too much in this class, but that is a smart way to program to prevent errors in large systems. But so mainly final as the keyword for a variable to make it constant. We talked about constructors. Can you overload constructors? Yeah, so we did a default, what is a default constructor? How many parameters? So default constructors have no parameters. And then you can overload it with one with multiple parameters, or one parameter or two parameters, whatever. Can you override constructors from the parent versus the child? So remember, like if you don't write your own constructors, it'll go up the hierarchy until it finds a constructor that matches those parameters. And of course, if you don't have a default constructor, there's one in the what class? The object class. So if you override it, you can override the constructor in your own class. How would you call the parent's constructor to do some of the work for you?
Super.
Super. Super is the keyword that we did that last time. Remember, your parents are super, so therefore, to call your parent, you call them super. I bet if you phoned home and like, hey, you're super, hey, super. No, that would make them happy, right? Like, we learned yours, okay. Getters and setters, we talked about that in this specific naming convention we're using this semester. The ToString, specific to Java, a very specific way. So when you try to print the object, now you could say that object like baseline system out print line baseline dot ToString, but we don't do that in Java. We just go system out print line baseline, my variable name, and we'll automatically call the ToString method. That's specific to Java, and very useful because we want to print out objects a lot. And if we didn't override the ToString method, what got printed? Yeah, it was like the name of the class, and then some kind of hash code for memory stuff. Static variables and static methods, so we just did that today. Visibility modifiers, so public, private, and protected. Java also has a default modifier if you leave off any modifiers. So if you don't put public, private, or protected, there's something called default. The details I want you to know, the level of detail I need you to know is that private is only within the class. Right? Only within the class can you view it. Public is anybody can have access to it. What is protected?
Only within the subclasses.
Yeah, if you inherit from it. And now there's a little bit more to protected, which has to do with packages. And the default, it has to do with packages. But I'm not worried about the packages stuff. So as long as you understand public, private, and protected being through the hierarchy, that's what we're going to focus on. We talked about this, that awkward conversation, referring to this particular class and the variables. We talked about overloading and overriding. So inheritance is where overriding is. We did the abstract class last time, which was with the parent class. If it's abstract, you cannot instantiate it. Protected, the object class, super, and overriding. Okay, so let's go through that worksheet, whatever we started the worksheet. The worksheet I don't give out. It's just like a little lecture bonus when we have time for these. All right. So last time we created the class, and then we did the textbook class, And then we did the interface with media. Given the following class, answer the questions below. So I think I still have it on the share zone. So we still have stuff on the share zone, which I believe has that class. And so the question is, we started with, I think we did the first 3 or 4, maybe? Let's do them real quick. Textbook TB equals new textbook, is that valid?
Yep.
Yeah, because the textbook is the variable textbook. Can you set a textbook variable equal to new book?
No.
Book was the parent, right? The parent class. So that you cannot do, because here we're assuming you have access to all the textbook methods, and a book object doesn't have those variables. Textbook TB equals new media. Media is an interface, right? In this example. So that does not make sense because you don't instantiate interfaces. Book B equals new book.
Well, book is an abstract class.
Right? Is book abstract? Then can you instantiate it? No. So if it's an abstract class, you cannot instantiate it. Book B equals new textbook.
Yeah.
Yes. Book B equals new media. What's wrong with that?
Oh, it's
All of it.
Lots. Definitely cannot instantiate an interface. So that would be a problem. Media M equals new book.
No.
What's wrong with that?
Book is abstract.
Abstract.
Book is abstract, so you cannot instantiate it. So when I say you cannot instantiate, vocabulary very important, that means equals new and then the class type. Media M equals new textbook.
Yes.
You can't do that.
So media was the interface equals new textbook. As long as book implements the interface, then we're good to go, right? Question?
Sorry, if book wasn't abstract, did you have G?
Yeah, then it changes a lot of things, right? So if book is not abstract, then we can do equals new book. And then we'd have to look at the relationship. So there might be, you still can't do textbook TB equals new book. Media M equals new media.
No.
Media is an interface, cannot instantiate it. So which of the correct answers in number 1 are polymorphic references? Oh, let's go back. All right, wait. See, I really want to, the first time I taught this class, I was like the midterm or something, or final exam, and people didn't know what a polymorphic reference was. I swore since that day I would drill it into you what a polymorphic reference was, because we're going to use it a lot. So, all right, so going at the top. Number 1, it's valid, but is it a polymorphic? No, because textbook is a textbook. Number B was invalid because you cannot instantiate book. And you can't set the subclass equal to the parent. Third one is invalid because of the interface. It cannot instantiate. D was invalid because new book cannot instantiate abstract. How about E? Is that polymorphic?
Yes.
Yeah, and it's valid and it's polymorphic. How about F was not valid. G, not valid. H was valid. Is this polymorphic? Yep. And I was not valid. So polymorphic is when it's really a different data type, but still works. Like you can still do that. So how would you instantiate an instance of the book class? Oh, it's time's up. Quick answer? Get rid of the abstract. Got to get rid of the abstract keyword. Make sure you implement all the stuff in the interface. Okay.